Now that we've talked a bit about the inverse of a matrix and how to compute it, let's look at some properties of it. Right? So here we're going to say A should be an invertible matrix. Right? Remember in particular that this does mean it's a square matrix. Okay? All right, I want K to be a positive integer. And I want C to be a non-zero scalar. Let me put that back there. Non-zero scalar. All right. Then, okay, so then A inverse, A to the K, CA, and A transpose are all invertible. And here are some properties that they have. If we inverse the inverse, well, of course we should get back to the original thing, right? Hopefully that makes sense. Okay. The second thing is if we take AK and invert that, all right, what we get is A inverse times A inverse times A inverse a bunch of times. In particular, K times. Right? And that's going to be equal to A inverse to the kth power. Right? Remember, if we take a matrix and we raise it to a power, that just means multiply that matrix over and over and over. Like A cubed would be A times A times A. Right? We don't raise the individual entries to a power, we multiply A by itself several times. This is what exponents mean. Okay? 3. If we take a scalar and we multiply it times A inverse, well, that's going to be 1 over C times A inverse. Okay? And the fourth one, if we take the transpose and invert that, that's equal to the inverse transposed. All right, so there's some pretty interesting things we get out of this. So, as an example here, how we can prove this kind of stuff. So let's look at, say, property 3. All right, how can we prove things like this? So we're claiming that the inverse of C times A is equal to 1 over C times A inverse. All right. Now remember, the key thing is that the inverse of a matrix is unique, right? So what we need to check, so let's say if this matrix here is B, let's say we make B equal to C times A, just for some shorthand. We need to show B inverse is the identity, and B inverse B is the identity. Okay? So, in the first one, in this step here, B inverse, what we'd be looking at is, okay, C times A times what we claim is the inverse, which is 1 over C. 1 over C A inverse. All right. Now remember, with scalar multiplication, we can put the scalars wherever we want. So we can do C times 1 over C, and then A times A inverse. But C times 1 over C is 1. A times A inverse is the identity matrix, so this would be 1 times the identity, which is the identity. All right, and you can do a similar thing for this one. All right, and we just multiply it in the other order. I don't know why I keep wanting to write 3 there. I think it's because it's property 3, and that's just on my mind. Anyway, again, we just, rearrange things here. And we have the exact same thing. Because again, A inverse times A, we know that's the identity. Right? So we would say here, since inverses are unique, CA inverse must be 1 over C A inverse. All right, so it's pretty neat how we can sort of exploit that. And notice, we didn't have to go all the way down to, the entries of the matrix this time. We could just use properties. Or in this case, we use the definition of the inverse of a matrix. Right? So hopefully this will, help you out doing some computations here with this and some of the proofs of this stuff. All right? One last thing that's really interesting here that we'll end this video with is another property, but this one we'll call a theorem. All right? And if we have A and B invertible matrices, then the inverse of a product is the product of the inverses, but in the opposite order. All right? So why is this true? Well, again, to prove this, we do a similar thing. Right? So we're claiming that AB, the inverse of AB should be this. Right? So we're going to use associativity here to move parentheses around. Right? And then that's A times the identity times A inverse. But that's just A times A inverse, which that is equal to the identity, which is what we want. And I'll leave it to you guys to check the same works out if we do this in the opposite order. Right, so I'll leave this to you to check the details of. All right. So I'll leave that for you. So it's really interesting. You're going to see a lot of these operations you do on matrices. If you do it to a product, it's going to flip the order. Anyway, so we'll leave that there. And see you in the next video.